Hey everybody, Mr. Ryan is back here. This is Quadratics video and restart. Hey everybody, this is Mr. Ryan talking. This is Quadratics video number 5. This one is on transformations. So what that means is basically how parabolas move around, whether it's left, right, up, down, stretching, shrinking, stuff like that. So in chapter 2 we did this with absolute value functions. We're going to do it with parabolas today. We're going to talk about a few things with this. So to review, of course, this is your standard form for all parabolas or quadratic equations, right? You have y equals ax squared plus bx plus c. There's your a, b, and c. They were capitalized last time. It doesn't matter if they're capitalized or lowercase. In this case, no difference. Again, that's your quadratic term, the ax squared. The b is your linear term, and that's your constant, just a number term. So the questions for today: what happens when A changes, positive, negative, bigger, smaller, B changes, and when C changes? Because each of these letters, when they change, right, when these numbers get bigger, smaller, positive, negative, different things happen. So we're going to look at that today a little bit, and then do a lot more of this on Friday in class. So first off, what about A? So what I have right here in orange, or whatever color it turns into when the screen gets inverted, I have y equals x squared. That's this graph right here. Okay? That's my parent function. That's the most basic quadratic function there is. Notice that it goes up because a is more than 0. A is positive, right? Because a is 1 in this case. It's just a regular old-fashioned parabola. The next one, the second one, you see it right here, is the same exact graph except it's turned upside down. Well, it's turned upside down because that negative right there. Again, a is negative, right? It's less than 0. It's negative 1. So the whole this function here just got turned over. So it got reflected over this line right there. So negatives will be upside down, which I think you already knew. The third one, y equals 2x. It's just like the first one, right? Here's the first one. And this inside one's the second one. That 2 makes it narrower, makes it grow faster. So you see it kind of jumps up quicker. As opposed to this fourth one, y equals negative 1/3 x squared. That's this one down here. It's somewhat wider. It's also negative, so it got turned upside down. And so being negative, it grows slower. So it takes longer to get down on either side. So it kind of gets stretched out, wider. You see like that. So basically, for A, when A is larger, the graph gets steeper, narrower, skinnier, however you want to call it. So something like this, right, very narrow, or something like this if it's negative. Right, very skinny. That's what happens when A is big. A is like 2 or 5 or 10 or something like that. When A is small, so somewhat tiny, and I mean by tiny I mean less than 1, so a fraction. Something like, 1/2, or like the one before 1/3 or 2/3, something that's less than 1, right? Some fraction like this. Then your parabola gets wider or fatter, same thing, or stretched apart, so it's more like this, where it's kind of wider. So it basically opens up a little bit when your A is a fraction like that. So looking here, right, this third equation, right, bigger than 1, so it got skinnier. This one here is less than 1 because it's 1/3, it's a fraction, so it got wider and fatter. Next level we're going to look at is not B, but C. I'll explain why in a second. So C, this is your move up and down coefficient or letter. So this first one here is again the parent function, y equals x squared, the most basic one. This one here, the second one, is up here. What changed? The only thing that changed is I have x squared plus 3. So what happened? This graph from the first one to the second one just went up 3 spots. If you can't see the graph because the colors are inverted, it went up 1, 2, 3 spaces. So this plus 3 makes it go up 3. So look at the third one. Can you figure it out? Y equals x squared minus 4. So it's down here. And if you can't see the grid lines, from the original equation, it went down 1, 2, 3, 4 spaces. So that minus 4 made it go down by 4 spots. So again, this is kind of like the absolute value functions from chapter 2, way back in October-ish when we did this. So when you put a plus at the end, it makes it go up. The minus at the end makes it go down to here. But otherwise, they're all positive 1 x squareds, so they all have the exact same parabola, just picked up or placed down. So C is pretty simple for the most part. When C gets bigger, your parabola shifts up, right? So it gets basically just picked up and lifted up a little higher in the graph. When that C term gets smaller, then your parabola gets, shifted down or slid down or, carried down, however you want to talk about it. With standard form, one kind of bonus thing here, C is also your y-intercept. Look at this function right here. Y equals 3x squared minus 8x plus 4. So to find the y-intercept, you just have to make x 0. This goes back to like 3 graphing or algebra 1, just graphing good old-fashioned lines. So you make x 0. So in this function here, if I make x 0, well then y will be, this is 0, 3x squared, if x is 0, that's 0. If it's negative 8 times 0, you have 0 again. So you have this and that, and then 4 is still 4. So it means that your y-intercept is 4, which is also your C term. So C is also your y-intercept. So when you're graphing parabolas, you can plot that point right away. Okay, so then what about B? So what about B? Well, for right now, don't worry about B. B is somewhat more complicated. I'll probably have an extra credit assignment dealing with B in the future because that's not something I'm going to really test all of you on. But again, it'll be a kind of extra credit thing. If you take pre-calc, you'll do more with this B term next year. I mean, it's not impossible. It's just more than I want to cover right now in this class. So we'll look at the basics as far as parabolas go in this class. So anyways, don't worry about that. Now, the only thing with B you want to worry about is the vertex, right? Going back to the last 2 videos that Ms. Pikaki made, right? You use your B term to find your vertex, or with the ones I made, the axis of symmetry. So your x for the axis of symmetry or the vertex is negative b over 2a. So, to review again, here's a function, y equals negative 2x squared plus 6x plus 5. So your vertex, right, negative b, so negative 6. 2a is negative 4, so it's 3/2. That's really the only thing for right now that you have to worry about with B. It's just find your vertex, your axis of symmetry, stuff like that. Okay, last thing here, and then I'll be done. So I want you to graph these 3 functions, y equals x squared minus 4, and y equals negative 2x squared plus 2. I know the video is running a little bit longer. However, there's only one assigned today, so I don't feel as bad. Okay, so I'm going to make a table for the first one, just to review again, right? Y equals x squared. So I know for a fact that when x is 0, y is 0. When x is negative 1, y is 1. And when x is negative 2, y is 4. It's a really bad 4. Let's try that again. Okay. When x is 1, y is 1. And when x is 2, y is 4. So I'm just going to kind of plot this quickly so it looks something like this. So this is me drawing the first graph, the one up here. The second one, x squared minus 4. Well, what's going to happen? Just move down by 4. So I'm just going to take every single point and go down by 4. So, forget that. So I'm going to start right there, and then I'm going to move all these points. I moved these two down by 4. You can't see it, of course, but then I move these points down by 4. So that one looks like this. Could also make a table for the green one and just make everything 4 less, like I'm doing here. Okay? And the last one, this negative 2x squared plus 2. There's two things happening here. I'm going up 2, so my y-intercept is my c term, because there is no b term here. So I'm going to start right here. That's my first point, my vertex, and the y-intercept. And then because it's negative 2, it's going to be upside down and steeper. So it actually looks something like this. Now I'm doing a rough sketch here. I'm not actually plotting exact points, but just showing you what it looks like. So you can kind of compare all three of these. So there you go, just kind of a quick little review here. We will go over this a lot on Friday with that half day we have, as far as doing a lot of practice with just seeing changes. This won't be a heavily tested thing in the future, but I do want you guys to just logically see changes with graphs and stuff like that, because it's stuff that you'll see later on as well. And it's good logic anyway. So anyways, I'm done for now. Thanks for sticking with this. I really appreciate it, and I will see you in class next time. Bye-bye.